About normal distributions. We're going to talk about the standard normal distribution. And what we're talking about there is all normal distributions are the same if we measure in units of size sigma from the mean as the center. Meaning if we measure by z-scores, we have distributions that are identical. So here's what that means. So the standard normal distribution is the normal distribution with a mean 0 and standard deviation of 1. If x has any normal distribution as this, then we can standardize this by computing z-scores for everything, and now we have a normal distribution that has a mean of 0 and a standard deviation of 1. Amazing, fascinating, and wonderful, because that allows us to look at all standardized normal distributions the same way. So this is what every picture looks like. What was the mean in the middle is now 0. What was one standard deviation away, whatever that, how big standard deviation was, it's now simply just 1. That's kind of nice. So because all normal distributions are the same when they're standardized, we can use a single table to calculate any area under that curve. And table A in our book, and it's a table that you need to be familiar with for AP, but it's a table of areas under the standard normal curve. The table for each value z is the area under the curve to the left of z. That's important. That number measures the area from the z all the way to the left of this curve. So here's an example. Here's part of our table. We want the probability that z is less than 0.81. So we're using table A. The rows represent the 10th digit. The columns represent the 100th digit. So 0.81, we look at the 0.8 row, and then the 100th column, and our final percentage is where the two overlap. It's 0.791, and it corresponds to this picture. So we have our normal curve, our z-score of 0.81. Everything to the left of that, this blue shaded area, has an area of 0.7910. So let us find some areas under the standard normal curve. Couple examples. So here we want the proportion, the percentage of observations from our standard normal distribution that are between negative 1.25 and 0.81. Well, if we look up in the table, and we just did, the area that corresponds to 0.81, it's 0.7910. The area to the left of negative 1.25, and the sign is not important since this bell curve is symmetric. So we're looking up 1.25, and we find the area is 0.1056. Well, to find the area between these two, between the 0.81 and the negative 1.25, we're going to subtract. We take the big area minus the little area, and that gives us this picture, which is 0.6854. Another approach that we could have used would be knowing that the area to the left of our z-score is 0.125 of that z-score of negative 1.25 is 0.1056. To the right of 0.81 would be 0.2090. Take 1 minus this up here, and that tells us what's in this upper tail. And the area that's not represented in the unshaded parts, we found the two tails. We can just do 1 minus those two areas to get what's in between. And in the next video, we'll pick up with how to do some calculations with this.